Hello everyone. Today our topic is mirrors, and in this topic we will talk about plane mirror. Generally, we use plane mirrors in our daily life. For example, we use plane mirrors in our living room, in our washrooms, bathroom mirror, or a dressing mirror. So, what you see when you look at the mirror? You see yourself. You see yourself. Like your height is same, your hand movements are same. What is the size of your shape, your height? Everything will be similar. What might be the reason why it is similar in the mirror? For example, imagine this to be a mirror. This is the behind the mirror. Let us imagine this is the behind the mirror and this is the reflecting surface. Reflecting surface means where the light is falling on the mirror. That is called as a reflecting surface. Imagine an object is standing over here. The light is passing from the object. The light is passing from the object and it is reflecting on the mirror. There are so many light rays that are passing from the top to the bottom of the object and they are reflecting on the mirror. After reflecting, what happens? The property of the light is it bounces back. It bounces back from the reflecting point. From which point they are reflecting, they again bounce back in the opposite direction. They bounce back in an opposite direction. If we enlarge these light rays behind the mirror, now you see the same object. That means the height of an object is same, the size of an object is same. So in this way, the reflection happens in the plane mirror, where the object height is equal to the image height. The size is also similar of object and the image. So that is the reason we use these mirrors in our daily life. So the next one is spherical mirror. We have two types of spherical mirrors. First one is the concave mirror. And the second one is convex mirror. Coming to concave mirror, the name itself is saying, for example, imagine cave. Cave is something but a whole kind of thing where something is going inside. So imagine this to be a cave. So what happens in a concave mirror, when the light from a source, that might be a tube light source or sunlight, for whatever might be the source, when the light is entering into the concave mirror, inside this is the reflecting surface. The reflecting surface is inside. So what happens when the light touches the reflecting surface? It hits the reflecting surface and it bounces back. It hits the reflecting surface and it bounces back. So here what happens? The light is coming closer to one single point. Here the light is getting closer to one single point. That is the reason concave mirrors are called as converging mirrors. These are called as converging mirror because what happens? The reflecting light is hitting the surface and these lights are coming closer and joining together at a point. That is the reason we call them as converging mirror. Here the light is coming closer. Whereas coming to convex mirror, the reflecting surface is outside. It is outside. This is the reflecting surface. Here the reflecting surface is there. So when the light from a source is hitting the reflecting surface, the light is touching the surface and moving back. They are moving back. The reflecting surface is outside. This is not the reflecting surface. There is no reflecting surface here. So this is the reflecting surface. This part is the reflecting surface. So I hope you understood the differences between a concave mirror and a convex mirror, where a concave is a C-shaped mirror where the light is entering inside the C and the reflecting surface is inside the C. The light is touching it and moving forward, and they all are coming together at a point. That is the reason concave is called as a converging mirror. Whereas talking about convex mirror, the reflecting surface is outside the sea. So the light rays are diverging. They are not joining at a point here. In convex mirror, the light rays are not touching anywhere. They are moving away from the light. That is the reason they are called as diverging mirrors. They are called as diverging mirror. So in the earlier topic, we learnt about the concave mirror and the convex mirror. So now where do we use this concave mirror and where do we use this convex mirror? For that, let us first understand how the image is formed due to the two mirrors. Then we will see the purpose of using the mirrors. Before that, we will be learning a concept of ray diagrams. For that, we have 4 rules. 4 rules to draw the ray diagrams. For that, we need to learn certain terms. This horizontal line is called as principal axis. This horizontal line is termed to be principal axis. This point is called as curvature, or we will be denoted by C. Curvature or C. We will also call it as center of curvature. C is center of curvature. After that, we have a point called F, which is also called as focus. This point is called as pole. So based on these 4 things, we are going to draw ray diagrams. The one is principal axis, center of curvature, focus and a pole. So before drawing the ray diagrams, we have certain 4 rules to draw the ray diagrams for concave mirror. So this is a principal axis, point C is center of curvature, point F is focus and point P is pole, where the mirror or the concave mirror is passing through. For example, if a light ray from a sunlight or from a tube light, from anywhere when a light is passing parallel to the principal axis, this is the principal axis. This line is parallel to the principal axis. When the light ray is parallel to the principal axis, after touching the reflecting surface, it will pass from the focus. The first rule is when the line is parallel to the principal axis, after touching the reflecting surface, it is passing out from the focus. This is the first rule. Yeah. In the earlier thing we have seen, when the light ray is passing parallel, it is from the focus. Now, this is opposite. When the light ray is passing itself from the focus, when the light ray is coming from the focus point, after reflecting the surface, it is going parallel. It is moving out parallel. When the light ray is coming from focus, it is parallel. It is opposite to the first rule. Next, rule 3. Focus. The third rule is when the light ray is passing from center of curvature, when the light ray is coming from center of curvature, always denote the arrow mark which is coming inside, put it inwards. When it is leaving outside, put it outwards. Okay, to show the variations. When the light ray is coming from the center of curvature, after touching the reflecting surface, the light ray again passes in the same way. Again it is passing along the same path. It is leaving in the same path. Now what might be the reason why the light is coming, touching the center of curvature and moving away? Because here the light ray is normally falling on the surface. It is not coming in a slanting position. It is not coming in a horizontal position or the vertical position, but it is normally coming in a perpendicular position. In a perpendicular position, it is touching the mirror, due to which the line, after striking the reflecting surface, it is moving back in the same direction. This is the last rule. When the light is coming and touching the reflecting surface at the pole, when the light is passing and touching the reflecting surface at the pole, after touching, it is passing away in a opposite direction. It is passing away in a opposite direction. If you see, you have laws of reflection. What is the second law? The second law states that angle of incidence is always equal to angle of reflection. That means the light which is coming in the same angle. For example, if the light is passing in 30 degrees angle, after touching the normal line, it is bouncing back in an opposite direction with an angle of 30 degrees. It is similar to the law of reflection. When the light ray is touching the pole, after reflection, it is bouncing back in the opposite direction. Thank you.